This is a review of a short quiz we had in Precalculus the last couple days, and this quiz is going to cover extrema, domain, and discontinuities. 4 problems. First problem here, Juan kicks a soccer ball off the ground. The height of the elevation in meters given by the equation ft equals negative 4.9 t squared plus 26.5 t, where t is in seconds. How much time is needed for the ball to reach its maximum height? Well, a couple of my students looked at this problem, and something by looking at these answers should just grab you right off the bat. If this problem is anywhere close to realistic, would it be reasonable for the time needed for a ball to reach its maximum height to be 35.8 seconds? Of course not. So provisionally I'm just going to cross off A, because that's one that just would not make sense on this planet and according to this formula for gravity, which is standard meter formula for gravity. And to save time, what I did is I graphed this equation in my T_CX calculator, but substituting x for t. So I go to the calculator with this function typed in, press enter, and I see this type of arrangement. Well, you can already see if you have time on the x-axis versus height on the y-axis, you understand probably what the answer is already. You're going to be right around 3 seconds or so. 1, 2, 3, 4, 5. Well, yeah, 2.5 seconds, something like that. Anyway, to dispel any doubt, we just can go trace, press menu, trace, graph trace, and as we go up in time, we're going to reach a maximum height that the calculator tells us. Where is that thing? You should say max. Well, for some reason it's not doing that. Anyway, you can kind of see here, I usually say max at the top. Anyway, you see the coordinate pair 2.7 comma 35.8. Okay, back here 2.7, oops, wrong one. Is that it? Yeah. So you have 2.7 comma 35.8. So that's our coordinate pair. So I try to tell my students that this little crossword puzzle thing, when, what, okay? So your when, the time, is going to usually be an x coordinate value, and that's going to be, in this case, 2.7, as in 2.7 seconds. And if you think a little bit, that's certainly more reasonable than the other answers. This 5.4 seconds would be how much time it would take for that ball to return to the ground after being kicked. Next, the rational function h of x equals x squared over x times quantity x plus 4 has a removable discontinuity. What is the x value of that removable discontinuity? So if you understand pretty well what removable discontinuities are, you should be able to see what the answer is right off the bat. And just in case you can't, what I did is I, like the other one, I entered this function in advance, which we're going to go to right now. So I go up to it, and there it is, entered. Got to enter that time sign, x times, or else the calculator is going to recognize this as text and give you an error message. But anyway, this is it. You see here at x equals -4, that is a vertical asymptote, which represents a non-removable discontinuity. So there's a non-removable discontinuity at x equals 4. Now, at x equals 0, how can we tell that? We can't see any break at 0, but if we go to Control T, we go to table view, and at x equals 0, we have undefined. And so, not visible, but undefined, that would be a point or removable discontinuity, sometimes called a hole. So we will say x equals 0 is our removable discontinuity that you cannot see by the graph alone. Another thing, reason we call this removable discontinuity, is that you can remove this x equals 0 discontinuity algebraically. So if we rewrite x squared as x times x and write that as x over quantity x plus 4, we can remove this discontinuity algebraically. Okay, so the function is going to look very much like x over x plus 4, and it should have a horizontal asymptote of 1. Yeah, that's right. So really that's it. Next, which of the following functions has as its domain the intervals greater than negative infinity to 3, and then greater than 3, less than infinity. Well, the temptation would be perhaps to choose answer choice A, but if you take x minus 3, and we know we can't divide by 0, and set that not equal 0, and add 3 to both sides of this inequality, we have x cannot equal 3. Okay, and 3 is the discontinuity right here in this interval notation. So our correct answer for this one is B. The last one we're going to look at here is maybe kind of hard to see. I pulled it off a test prep guide for PSAT, and so in the taking the picture and the contrast and all, it didn't come out too clear. I did my best. So we have this graph. It says what is the minimum value of the function graphed on the xy plane shown between x equals negative 4 to x equals 6. And you see this graph here. I'm going to go ahead and trace it in red. Okay. And you got an xy coordinate plane here. Okay, key values. Maximum x value is 6, minimum x value here is negative 4, and then minimum y value is going to be down here at negative 2. Then the maximum y value would be up here at 4. So if you're interested in the minimum value, okay, and that's understanding the value is going to be output data. Okay, so it'd be almost like domain value. I'm making up another little crossword, right? So your value is going to be your y value. The lowest one we see is here at x equals negative 4, y equals negative 2. So negative 2 is our correct answer. So that's all we have here. A few questions. We're reviewing what we've covered a bit of in pre-calculus so far this year. Good luck, and thanks for viewing.